Hey, it's Dr. Ronnie here, and I am going to go through a little bit of collab to do some engineering economics calculations. I teach engineering economics, and one of the things I do say in engineering econ is there really is only one equation. So, let's look at this. I'm going to create a little code block here in my collab, and when you're dealing with an engineering economics type of question, you will have, there's two equations. There's a present worth equation. So we'll just actually start with PW equals, well, it's equal to 1 plus I to the n. Now, slight problem with that is that, well, we don't have an I and we don't have an n. Okay, and it's actually equal to the value at another point in time times that. So, okay, so let's look at this. What is that actually saying? It's saying that money changes value over time. And what are the two variables? The variables are I, which is an interest rate. 0.05 is what we'll use for this example here. And it also has a number of periods. Now, if I is an annual interest rate, then the number of periods would be the number of years. And if I know the future worth of something, what it actually is in the future, oops, then we can calculate its present value. Simple equation there. And that actually is almost every single equation in engineering economics is derived from this one equation. So let's say the future worth is equal to 10,000. And we run this. Okay. Oops. And we're waiting. And note, this is worth noting, an unsupported operator that. Well, the problem with that is that it doesn't actually support that. We're used to using it. You can use it in Excel, but we are going to need to do something else. So, how does this work? Well, the math library has your solution. So we're going to use math library. Take that. Okay, here we go. Take the caps lock off. Math dot. Now, what do you think? And notice that when I'm in Colab, it gives me the different functions that are in the library. So if you look here, it might not be obvious to you. If you did some of the other things, you might notice that there's, oh, look at that, degrees. I didn't give that one to you before. I actually gave you the number to multiply to go from radians to degrees, but there you go. What does degrees do? It converts from radians to degrees, and it's in the math library. But that's not the one we're looking for. We're actually looking for this one down here in the P's, POW. And it's a function, so it actually has to have arguments. Now, supports float or index, but what we're going to do is we're going to say, okay, what we don't know is what exactly, how does this work? So, in this case, you might want to jump to the documentation. I've kind of helped you out a little bit here, but let's just say that you've got two arguments typically in the power. What you're going to be raising and what power you're going to raise it to. Whoops. And then we can print this. Well, let's try that, see what happens. So what we found was that if I have an I of 0.05, an N of 10, and a future worth, what that's saying is something's worth $10,000 10 years in the future. What's it worth right now? Okay. So what does that mean? If I were to invest $6,139.13, there's going to be some round off here. Right now at 5% interest, in 10 years, I would have $10,000. Well, this should be very useful to you as you are solving the problem that I gave you, which is the problem of figuring out whether something is a good investment. So if I were to invest $10,000 now, and I were able to then sell what I invested the $10,000 in 10 years in the future for $10,000, its current future value, present worth is $6,139.13. All right, well, there's another piece of this too. In the problem that I gave you, I also said that this thing that you're investing the money in makes you money. So let's say it makes you $100 a year for those 10 years. Well, we can use a for loop. Okay. Oops, not equals. It's in range. Now, I is actually in this case the year, it is the N. So in year 1, okay, this is going to be, I can calculate the present worth. Well, here's something that I can do is I'm just going to print that. And I'm going to set the value at what I'm getting at any given year equal to 100. I'm going to get $100 in year I, and I want to know what that's really worth to me right this minute. Okay, now I'm not going to go into all the details of future worth and present worth and all that. That's actually covered in engineering econ, and I gave you some links for a little bit of understanding. But the basic understanding is simple. If I invest money right now, it's going to increase in value over time so that it's more in the future. If I am getting money at a certain point in time and I look at what that is actually worth at the present time, I can use the equation present worth from the future worth. Now, so in year 1, I know that I can take the value of that value that will, well, say, let's say this is called an amount. Value is probably the wrong term. So let's just say, let's go here and say print amount, and I want to know what it is worth now, not what it's worth, what I'm getting, the amount that I'm getting in year 1, year 2, year 3. I want to see it for now. Well, this was pretty much the exact same thing that I just did, math.how, only now it's 1 plus I, which I'm going to use the same I. Okay, but instead of using, oh, and I've got a problem here because interest and I are the same thing. Well, I'm just going to call this then interest, not I. So I'll go over here and I'll change this to interest. Notice it told me that there was a problem there. And I can fix this. Now, 1 plus interest, and each year is actually now I. So let's see what happens there. Well, and look at that. That's kind of interesting that, and you can see that number go down. So as I'm looking at it, that's the present worth of those things. I'm printing them, but you know what? Let's go one step further. Let's, instead of saying print, let's say V is equal to this. Okay. Because I'm going to use it. Okay, let's close this now, and I can print V. Let's go ahead and and its amount. And I like the fact that the debugging in here has gotten much better. And I'm going to print the V. But more important, I want to add them up. And actually, I don't really want to print the V. I just want to print the sum. All I really care about is that final one. Well, got one problem here. I need to go sum is equal to 0 at the beginning. Now I can do this. And I printed the sum each time. Comes up to $710 at the end. I don't want to print it each time. Let's just take it out of the loop because it was in the loop. Now if I run it, I've got the sum, there you go, of that $100. So all those $100 that I'm making off of whatever that I'm making each of these years, and I look at that as a present value of what it's worth to me right this minute, that's the number. Okay. Now, this does cover some concepts that we cover in tremendous levels of detail in engineering economics, the concept of time value of money. Because money changes value over time. Money is not constant value. So $100 today is worth a different amount to me today than $100 somewhere in the future. Or an easier way to think about it, if you have a problem with that, is saying, if I have $100 today and I put it into something that bears interest, which I can always do, it's going to change value as I earn interest on it, especially if the interest is being compounded. That's the basic concept of time value of money. And there really is one equation, even though I show a ton of equations, because this, by the way, is called an annuity right here. Okay? Where I have something that is either giving me money over a period of time or is a payment over a period of time. That concept is called an annuity. Okay. And you can call it other things because they are called by other things, but the generic term of annuity works there. So if you were to look for an equation for the present worth of an annuity, you could easily do that. And instead of having to do this loop, you could do it with one equation. You'll get to that when you get to engineering econ. If you've had engineering econ, you'll already know how to do this. I think this gives you enough information to solve the problem that you have for this week. With simple, and you can use the code that I use. Okay. I'm wondering now if I do a comment here and I go for present worth of an annuity. I'm just doing this because I'm curious if the AI will kick off and try to find that equation for me. It didn't, but that's okay. I was just, because what I'm finding is that Colab is actually getting kind of intelligent as it goes out and searches the internet for you. And maybe if you do it with the text portion here, you might actually get that. Either way you put it, if I were to go to Google or Bing, and I was to go present worth of an annuity, lots of calculators out there for you to use. So I guess I probably would have to specify the equation. By the way, we can do, there it is, present value, present worth, present value, and that's times 1 minus 1 plus I to the negative n, which, by the way, that should be show you that it's 1 over 1 plus I over I. And that would actually directly calculate the exact same thing this loop did for you here. All right. Once again, I said I think I've given you what you need to do this. I am actually in engineering econ working on creating Colab solutions to all the examples that I do the calculations for you. I've already done it in Excel because most people that do financial calculations work in Excel. But you being engineers, Python, you need to know how to use it. And oh, and while I'm at this, I wonder if, and how would I want, if I suppose there happened to be a set of financial functions for you in Python, how would you find them? Well, I think I gave you the answer to that question, and I usually use Google, and look at that. Pandas, which, well, you're going to use Pandas later for stuff like that. FFN, financial functions for Python. And I think what you'll find is that, and it's actually right there built into NumPy, right there. It's actually very useful in Pandas too. Once you get to Pandas, you're going to be pretty excited to see what Pandas can do. Anyway, that's it for now. This should help you out with this next problem.